Good morning, y'all. So I'm not here today, obviously. So we have about 5, 10 minutes worth of notes, maybe less, and then the rest of the time will be for you to work on your homework. So first things first, couple reminders. I'll be back tomorrow. So for anybody that needs the retest, I will be back after school. You can take the retest tomorrow after school, and then Monday you have your partner quiz. So make sure we study that. So, our joke of the day is I submitted 10 puns to a dad joke contest to see if any of my jokes made the finals. Sadly, though, no pun intended. All right. So, what we're doing today. So far we've been working with polynomial inequalities and figuring out when is it positive, when is it negative, right? So for polynomial inequalities, they change whenever they're equal to zero, right? Or they possibly change at zeros. Now for a rational inequality, which is what we have here, not only can they change at their zeros, but they can also change from positive to negative at their point of discontinuity. And so we got to take that into account, right? So we approach it the same exact way. We're still going to end up doing a little chart or a little table and figuring out when is it positive, when is it negative. The only difference then is not only are we looking for zeros, but we're also looking to see where it's discontinuous, right? And so for fractions, the only time that it's discontinuous is when the denominator is equal to zero. And so here, before we do anything, I have x as equals 6 and x equals -1. These are the points of discontinuity, right? So at these 2 points, my function does not exist, so therefore I cannot be those points. So I got to figure out what's happening to the left, what's happening to the right, etc., right? So then we got to figure out, okay, well, when is it going to equal to 0, right? Because if we kind of ignore this and make it equal sign, if I ask you to solve for 0, then we would have to go that way, right? So our first approach is exactly how we did the other day, right? So we multiply the denominators over. So on the left side, I have 4x plus 4. And on the right side here, I'll color code this for you. The right side, I have, when I multiply these two over, I still have my plus in the middle, 2x minus 12, and then all over. Now, when I multiply these two, I'm just going to keep them together because it'll help me. And then we have the x plus 1. And then we still have greater than 0, right? So right off the bat, we want the stuff that's greater than 0, which means I'm looking for all the positive intervals, okay? So let's keep going. So on the numerator, we are going to combine like terms. So when we combine like terms, everything that has an x, we're going to put it together. So here we have 4x plus another 2x, which gives us 6x. And then we have this positive 4 minus 12, which gives us negative 8, all over x minus 6, x plus 1. Okay. And so then from here, the next step would be to multiply the bottom over, which is x minus 6, x plus 1. But then what happens when you multiply anything by 0? It goes away. So here it cancels, and I am left with the 6x minus 8 greater than 0. Move the 8 over, divide, and we get x is greater than 8, 6 if we simplify that, then we end up with positive 4 over 3. Sorry. And so now, so now we have our values or our numbers to check, right? And so we want to figure out what's happening in these values, right? So here, we're going to do a little chart. So we have -1, 4/3. So we're going to test values just how we did for the other functions. Now, I'm going to clean this up a little bit, and I'm going to rewrite my my rational inequality a little neater up here, just so that we can kind of see it a little better, right? So we have 6x minus 8 over x minus 6 and x plus 1. Okay, so in this equation is where I'm going to check my values, right? So, or check my test values. So, so here we go. So any number that's to the left of -1. So I want to choose a number that's kind of easy to check, right? So I'm going to go with -10. Does it have to be -10? No, it can be -2, -3, -4, -5, and -500, -1,000. As long as to the left of -1, then we're good, right? So let's do a little bit of mental math. Again, we're not really worried about the actual value. We just want to know whether it's going to end up positive or negative, right? So here we go. So if I plug in -10 in here, I have -60 minus 8. That's negative on the numerator. Okay. And then at the bottom right one, so in here, so we have -10 minus 6 is definitely negative. -10 plus 1 is still negative. So now what we're working with. So we have a negative in the numerator, and then we have two negatives in the denominator, which end up being positive, right? Right, because these two multiply, give you positive. But now we have a negative in the numerator and a positive in the denominator, which makes it overall negative. Okay. Now we got to choose a number between -1 and 4/3. Now, because we are going from a negative to a positive, then 0 is somewhere between here. So I'm going to choose 0 just because it's the easiest, right? So if I plug in 0, in here, all my x's go away, and I'm left with just the value, right? So the 6x goes away. I'm left with a -8. If I plug in 0 in here, I'm left with a -6, and I plug in 0 in here, I'm left with a +1. And we do the same thing, right? So on the numerator, we have a negative. In the denominator, we have a negative times a positive, which ends up being a negative. But then we have a negative over a negative, which ends up being positive. Okay, and we approach the same way every single time, right? So now, by the way, 4/3 is about 1.333, right? So don't choose 1 as your next value. Choose something that's a little bit more closer this way, right? So again, I don't want to choose something hard or something that's kind of close that's going to make me think a lot, right? So here, if I choose 5, that's kind of easy, right? We know, or we should know, multiples of 5. So if I plug in 5 in here, that's 30 minus 8, that's positive. 5 in here, that's 5 minus 6, that's negative. 5 plus 1, that's definitely positive. And so we're in the same situation in the denominator at least, where we have a negative times a positive, which is a negative. But now we have a positive over a negative, which means that this whole side is negative, right? And then we're going to choose another value somewhere to the right. And again, I want to choose something to make it easy, so let's go with 10. If I choose 10 as my test value, if I plug in 10 in here, that's 6 times 10, which is 60, minus 8, that is definitely a positive number. 10 minus 6 is positive. 10 plus 1 is definitely positive. And so we have positive, 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 which means overall it's going to be positive. And now we can go ahead and answer our question. We wanted stuff that was greater than, or in other words, we wanted the stuff that was positive, right? So when does that happen? Well, that's going to happen whenever x is from -infinity to -1. That's also, whoops, just kidding. My bad. Is going to happen between -1 and 4/3, as well as from 6 to infinity, right? So another way we could written this is x is between -1 and 4/3, or x is greater than 6. All right, so now I want you guys to try this next problem. So pause the video, take as long as you need, and then resume the video so that you can see the answer worked out. Look, you got this. Pause the video, no cheating. Okay, so I hope you actually pause the video. So the first thing that we need to do is we still got to figure out two things, right? What are my zeros and what are my points of this continuity, right? So my zeros, that's what I'm going to look for. Kind of how we've normally been doing. My point of discontinuity, remember, that's when the denominator is equal to 0. So in this case, when is the denominator equal to 0? Well, 4 minus 3 equals 0 whenever x equals, so move 3 over, divide by 4 whenever it's equal to 3/4, right? So here I have part of my solution, right? So then the next thing I got to do is figure out when is equal to 0. So if I'm trying to figure out when it's equal to 0, I first have to set it equal to 0. So with that being said, that means my first step then is to move the 1 over. So we have x plus 6 over 4x minus 3 minus 1 greater than 0. Great. So that tells me that I want the stuff that is in the positive side. Okay. And so from here, now we got something to work with, right? So first thing I'm going to do is I'm going to rewrite this 1 as 1 over 1. The reason I'm writing it as 1 over 1 is because I still 1, yes. And then when I multiply this over, it's not really going to cause me any issues, right? Because 1 times anything is just whatever you multiply by, right? So on the left side, I have x plus 6. On the right side, however, you have to be careful. I have that minus there, and I'm multiplying 1 times 4 minus 3. So the reason I'm doing it this way is because now I can see that I'm actually going to distribute that negative in the front. So I have x plus 6 minus 4x plus 3 over 4x minus 3 greater than 0, right? And so from here, we're going to finish it off, right? So I still got to figure out what my zeros are, which means that I got to figure out when the numerator is equal to 0. The reason that is because what happens when you multiply by the denominator on both sides to cancel out the fraction, it cancels out, right? Here goes away because anything times 0 is 0. So really what we're left with is when I combine like terms, right, so combined like terms, we got the x minus 4x, which is negative 3x. And then we have the positive 6 plus 3, which is plus 9 greater than 0. Move the 9 over, etc., etc. You got to be careful here, though, because, well, I guess it kind of doesn't really matter, just because in the end, we're going to end up doing our little chart, right? So here, when we divide by negative, or multiply by negative, we switch the inequality symbol. So here, right? So we have 3. So now we got to figure out, okay, well, do I want the stuff to the left, to the right, etc., etc., right? So that's 3/4, and this is 3, because those are the only two values that we got. Okay. Now, I want to put it into something that's kind of easy or kind of simple. And so in my case, we are going to bring it back. So this was my numerator stuff, right? So I have negative 3x plus 9 over my denominator, which was 4x minus 3. I'm going to try to make life a little simple. On the numerator, do we see a GCF? We should. That's a negative 3x minus 3 over 4x minus 3. Okay. All I've done so far is just rewrite my equation so it's a little bit easier to see. Could we have plugged it in here? Yeah, we just got to make sure that whatever I'm comparing it has got to be greater than 1, right? So now let's check, right? So something that's left of 3/4, we can choose 0. If I choose 0, plug 0 in here, that's 0 minus 3, that's negative. So here we have to be a little bit careful because we have a negative on the front. Then we have another negative that's coming from the inside of the parentheses, and at the bottom we have a negative. So from the other problem, we have negative, negative on numerator, which is positive, but then a positive times a negative means that overall is negative. A number between 3/4 and 3, yeah, we can choose 1, we can choose 2. Doesn't really matter as long as it's between 3/4 and 3. So I'm going to go with 1 just because I know 1 is somewhere between here, right? So here we chose 0. Here we're choosing 1. So if I choose 1, right, so plug in 1, that's 1 minus 3, which is negative 2. We still have a negative from the negative in the front. And then we plug in 2 in here. Now, sorry, not 2, 1. And that's 4 minus 3. 4 minus 3 is 1, which is positive. And so then we have negative and negative in the numerator, which is positive. So then we have positive over positive, which is overall a positive. And lastly, A number that's greater than 3. Well, let's go with 10. Again, does it have to be 10? No, it does not. If I plug in 10, inside the parentheses, I get a positive 7. On the outside, I have that negative 3. And then on the bottom, I have 40 minus 3, which is definitely positive. But in the numerator, I have a positive times a negative, which is a negative. And a negative over a positive is overall negative. And so now we can easily see what range, or sorry, what domain do I want? What that's going to be positive, and that is between 3/4 and 3. So my answer, my solution is from 3/4 to 3, or we can write x between 3/4 and 3.